Dear friends from Ukraine, I've just learned that you are supplied with newest MEK-ICS ventilators, so I hurry with my help on its use, what will save you some time, I hope. These ventilators were developed during COVID-19 pandemic and integrate a couple of innovative technologies functionalities. HFT700 is the first ventilator that integrates advanced functionalities designed to support patients from the first moment with high flow up to non-invasive B-level. My name is Przemysław Sadowski. I'm a biomedical engineer by profession and by education, a graduate from the Wrocław University of Technology, and for over a dozen of years I've been working with medical equipment with a special love for ventilators, anesthesia equipment and monitoring of human vital parameters. My mission is to provide professional, up-to-date knowledge related to medical equipment, the needs that inspired people to develop it, and practical information on its use. HFT700 ventilator is equipped with several innovative functionalities, such as central monitoring system for many ventilators, as we know it from intensive care patient monitoring systems, or target saturation feedback that automatically regulates the inspiratory fraction of oxygen to obtain the set value of SpO2 as measured in our patient. This functionality will be described in this movie. First, I will give some technical details of the device. We'll show how to configure the device before work, and then I will describe ventilation modes, and finally we will go through the description of data the ventilator presents on the screen during therapy. The HFT700 ventilator has a built-in turbine as a source of air and needs to be supplied only with oxygen. Thus, it does not require medical air supply. The HFT700 ventilator can be powered from central oxygen system or from a cylinder, both high and low pressure. In addition, the ventilator can be equipped with a battery module which allows you to transport the patient and start respiratory therapy on the way to the ambulance. Because, as we know, the faster we start the ventilation therapy, the better will be the result. The source of gases in the ventilator is a mixer consisting of an oxygen dosing valve and a turbine, which mixes oxygen with air in accordance with the required oxygen concentration. The HFT700 ventilator's turbine is protected by a filter that removes solid particles and bacteria, protects the inside of the ventilator and the patient. The diagram showing the construction of the device you can see on the screen. The precision pneumatics of the ventilator is equipped with two flow sensors, one to measure oxygen flow, the other to measure total gas flow to the patient. It has also oxygen sensor, thanks to which the ventilator can adjust oxygen concentration in the gas mixture automatically. That is the internal construction. Gas mixture leaves the ventilator through another filter, an antibacterial and antiviral filter, and I direct it to the humidifier to be heated and saturated with water vapor to the required level. The design of the ventilator allows for smooth regulation and measurement of the oxygen concentration in the breathing mixture, measurement and control of hemoglobin saturation with oxygen, SpO2 of course, and the other SpO2 related parameters such as perfusion index and the heart rate. Measurement of pressures in the respiratory tract and detecting inspiratory effort. Measurement of the volume delivered to the lungs despite of unavoidable leaks caused by non-invasive patient interface like TPs, cannula or facial mask. Measurement of the SF ratio, this is the ratio of SpO2 to FiO2 as a parameter equivalent to the ratio of the partial pressure of oxygen in arterial blood, PaO2 to FiO2 for early diagnosis of hypoxemia. Heart rate measurement, of course, perfusion index, as I mentioned earlier, related to SpO2, gas flow, temperature of the gas in the respiratory system. All these parameters will be described further in the movie. Now I will show how to connect different parts of the patient circuit to the ventilator, how to supply the ventilator with oxygen and how to switch it on. The ventilator has two oxygen ports at the back of it. This is a high oxygen pressure port, and this is low oxygen pressure port. We also have a power supply. Here is the main switch for the ventilator, and if your ventilator is equipped with a battery module, you will see another connector for the battery module. Front of the ventilator, under the cover, we can see a connector for SpO2 sensor, and here we can see a port for breath detection module, if your face mask is equipped with a special tube for breath detection. If not, of course, the ventilator can use internal system to detect the breath. In the upper part of the ventilator, we have two additional ports. This port is to connect the gas temperature sensor and the heater of the patient circuit. This port is the gas outlet from the ventilator. Here we install the humidifier chamber. Now I will show the components of patient circuit. The first component is a short tube equipped with a bacterial antiviral filter that is connected to the ventilator to the outlet port. This one. Another part is humidifier chamber, which we install here, and to which we connect the short tube. Next tube is the patient tube. This is a heated tube with a few ports. We see two ports for temperature sensors, and we have a cable to connect to the power source to supply the heater inside the tube. Then we have a cable which we connect in here, and to this port. Here is the port for the first temperature sensor. We can install the cable properly in the hooks of the patient circuit. And the last temperature sensor is connected here. Now the ventilator ready for use looks like this. After we have assembled the patient circuit, we can connect the patient interface. In our case, this is nasal cannula. Connect it like this. Now the ventilator is fully assembled and can be connected to the patient. Now, when we have the patient circuit assembled, we can switch the device on by pressing this button. If it doesn't start, it is possible that the main switch at the back of the device is off. Let's check. Yes, it's off. Now it's on. And now, by pressing the button, oh yeah, it's on. We have the first screen where we can choose new patient or the last one. We will choose a new patient, and we get a warning that the SpO2 probe is not connected. We will do it now. This is the SpO2 probe. This probe consists of two elements. The first one is the extension cable, and the second is the probe itself. Now we connect the probe to the socket. Done. And after we connected the probe, we have a few parameters. First is the patient ID. We can put some data if it's necessary. Second is the bed number. These two parameters are important if we want to use the device together with central monitoring system that integrates many of these devices. The third parameter is the ventilation mode. We will choose high flow mode at the beginning. And after we choose the high flow mode, we can calibrate the patient cannula. the patient circuit is fully assembled. I will move the SpO2 sensor further away. We put it on the table, and now we can calibrate we can choose which patient interface we want to calibrate, T-piece or cannula. We will choose cannula. Press OK. And now we have like 1 minute, usually it's shorter, 1 minute of time to calibrate the system. Flow zeroing and pressure zeroing success. Now the ventilator calibrates the patient circuit with some flow to determine what pressure is required to overcome the resistance of the patient circuit. Okay, after successful calibration, we can press the next button, and now we can configure the ventilation mode. The HFT700 ventilator has 3 operating modes, which I will discuss in details, but before I do that, I will describe the humidifier as a common to all ventilation modes. The humidifier of the ventilator that is fully integrated with it allows you to adjust the dew point temperature and the level of humidification of the gases. On one hand, the dew point temperature determines the temperature of the gases breathed by the patient, and on the other hand, the maximum water content in the breathing gas. At the temperature of 37 Celsius degrees, which is the temperature of a healthy individual, 1 liter of gas contains up to 44 milligrams of water. This is the amount of water that is contained in the gas exhaled by a patient whose body temperature is 37 Celsius degrees. The lower the gas temperature, the dew point, the lower the amount of water in the gas. If we want to increase the water content, we need to increase the gas temperature. This is the dew point. If the inspiratory gas contains the same amount of water, the patient does not lose water through the respiratory system, nor gains water this way. If we set the dew point temperature to 37 Celsius degrees, the gas reaching the patient will be heated to this temperature. The degree of water saturation will be regulated in a unitless range from 1 to 5, where 5 is the gas fully saturated with water. And of course, I know there are several different models of respiratory gas humidifiers on the market that approach humidification according to different logic. Some of them operate in automatic mode that allows you to choose between ventilation mode, between invasive or non-invasive ventilation mode, and changes gas temperature, and the humidifier delivers gas that is maximally saturated with water. Others, usually older humidifiers, allows you to regulate the temperature in the humidifier chamber and separately at the patient end of the circuit. The humidifier of the HFT700 ventilator allows you to regulate 2 and only 2 clinically important parameters: the temperature of the gas breathed by the patient and the degree of its saturation with water. The humidifier function can be disabled in CPAP and B-level modes. The dew point temperature can be changed in all ventilation modes. After we covered the humidifier, we can go into the details of operation modes. First, we will discuss the high flow with its functionality of automatically maintaining the set level of hemoglobin oxygen saturation, SpO2, and the gas humidifier, together with a complete set of parameters showing our patient condition. Now you can see the description of target saturation feedback. In the first step, the ventilator compares the measured SpO2 with the set value. If these two values are the same, nothing changes. The FiO2 remains constant. If the measured SpO2 is higher than the set, then the HFT700 will decrease FiO2. Less oxygen in the breathing mixture will decrease patient SpO2. If the measured SpO2 is lower than the set target, the HFT700 will increase oxygen content. The whole process is done by advanced regulator that does not allow for the rapid FiO2 decrease or increase for patient safety, or administer gas mixture with too high or too low oxygen content. All this is for our patient safety and to allow for minimal adjustment on the medical staff's side. The ventilator is equipped with alarm system, so if some parameter is outside of range, you will be, of course, informed, like now. Now we can go through the settings of high flow mode. Let's see. First, we can set, of course, the flow itself. We can choose between 5 liters per minute up to 60 liters per minute. Let's set 10. Another parameter is the sensitivity of a breath detector. You can choose between 0.2 to 3.0, sorry. Then we can select the detection source. Normally the detection source should be internal sensor, but if your mask is equipped with an additional line for breath detection, you can connect it here and choose respiratory detection line. If you don't want to use respiratory detection, you can switch it off. Let's stay with internal sensor. And here on the right side of the screen we have 2 arrows. Using these arrows we can change the configuration screen. Ventilation modes have a few configuration screens, depends on the functionality we choose. In this case, with high flow we have 3 configuration screens. The first configuration screen allows us to set the flow, the sensitivity and the detection source. The second screen allows us to set parameters related to target saturation feedback. This is the functionality that allows the ventilator to monitor the SpO2 of the patient and adjust the inspired fraction of oxygen in such a way that will control the patient saturation at the level we set. This is the target SpO2 parameter. Let's say we set 95%. This is SpO2 that we want the patient to have. Another parameter, the backup FiO2, is the oxygen content of the gas in case the patient removes the SpO2 sensor from its finger. So the ventilator has no data from the patient, cannot measure the SpO2, so will deliver 70% of oxygen. We can of course adjust this parameter according to our needs. Let's stay with 80. At the bottom of the screen we have 4 additional parameters grouped in 2 different fields. The first field is FiO2 range. So in order to get this target saturation, the ventilator can change the oxygen content in the breathing gas between minimum, which can be set between 21%, which is pure air of course, to some higher volume we set, and the maximum oxygen content. If we don't want for some reason to deliver to the patient pure oxygen, we can change this parameter, let's say to 80%. Then the ventilator will not deliver gas mixture which will contain more than 80% of oxygen. Another 2 parameters are time constants. These time constants are critical. The first one is increment interval. You can choose between 10 and 20 seconds, which means that the ventilator will increase, in this case, the oxygen content in the breathing gas 1% per every 20 seconds. If you change it to 10 seconds, if the saturation of the patient, the measured one, is lower than the target saturation, the ventilator will increase the FiO2 1% every 10 seconds. Another parameter, this is the decrement interval. In this case, you can choose between 30 seconds, 60, 90 and 120 seconds, which means that the ventilator will decrease the FiO2 in the breathing mixture 1% every 2 minutes, every 120 seconds. This is the second screen. Now let's switch to the third screen. On the third screen, we set the humidifier parameters, which is the dew point temperature, humidification level, which you can choose between 1 and 5. 5, of course, means that the gases are fully saturated with water in this temperature. And of course, we can switch on or off the target saturation feedback. That's the function that monitors the patient SpO2 and adjusts the FiO2 in the breathing gas. If we switch it off, now we have only two fields to set the high flow mode. Now we can set only flow, oxygen content, and parameters related to respiratory rate detection. Sorry. Okay, let's switch it on. After we have set all these parameters according to what we need, we can start the ventilation mode, confirm with OK, and now the ventilator delivers the flow we set before, changes the oxygen content in the breathing mixture, and if we install the SpO2 sensor correctly, we will also get hemoglobin oxygen saturation, which is 97% in my case. With this button, we can change the set of parameters that the ventilator will show to us. If we set all parameters, then we can observe the actual flow, the FiO2, which is 75% currently. We can also see the maximum and minimum oxygen concentration in the breathing mixture. We see the respiratory rate, which is not measured currently. We see SpO2, pulse rate, which is 106 per minute. We see perfusion index, and we see SF ratio. This SF ratio is a ratio between oxygen saturation, the measured volume, which is 98 divided by 0.78 FiO2. Okay, at the bottom of the screen we have a set of buttons. The first one, the home, displays the measured parameter screen. The second button allows us to change the parameters. The third one allows us to check the humidifier system, whether there are some errors and what are the settings of this. We can also, of course, change the settings here. Another button allows us to set alarm system. Then we can do some calibration, like oxygen calibration, like cannula calibration, and we also have O2 calculator, which allows us to calculate for how long our oxygen cylinder will be enough. Okay, now I will discuss the CPAP mode. CPAP mode is essentially a method of assisting breathing by continuous positive airway pressure with oxygen-enriched gas. The task of the ventilator is to maintain a constant pressure of the gases inhaled by the patient, which facilitates the filling of the lungs. The disadvantage of this solution is that on exhalation, this continuous positive airway pressure makes it difficult for the lungs to empty of the gases. The HFT700 ventilator provides assisting parameters. This is pressure assist plus and pressure assist minus, that increase the pressure during inspiratory phase of the breath up to 3 centimeters of water and decrease the pressure during expiratory phase up to -3 centimeters of water. Please note that these settings does not change the EPAP pressure, the PEEP pressure, which remains constant at the set level of CPAP. The pressure assist reduces the work of breathing, improves lungs filling and emptying during exhalation as the patient breathes out against a lower pressure in the patient circuit. You can also activate the auto start function that will start the ventilation after HFT700 detects patient inspiratory effort. This is oxygen-saving functionality, as the ventilator can be supplied from oxygen cylinder of limited capacity. Let's see how to set appropriate parameters. We choose CPAP mode, then we have to confirm our choice, and we see, after pressing this button, another 3 screens where we can change, adjust parameters for the ventilation. First, we set the CPAP pressure, then we adjust the oxygen content, and here we see the 2 assisting pressures. The PA plus is the pressure that will be applied additionally to CPAP pressure during inspiratory phase of the breath to assist the patient during inspiration. The second parameter, which is PA minus, now it's set to -3, is the pressure that the ventilator will apply to the patient during expiratory phase of the breath, which means that during expiratory phase the pressure will be decreased from 15 to 12 centimeters of water. Another screen allows us to set the trigger level to recognize the inspiratory phase by the ventilator, the rise time of the pressure, which can be chosen between slow, medium and fast, and we can also turn on or off the auto start function. The third screen allows us to set the dew point temperature and humidification level. As previously, this can be set between 1 and 5. After we have configured all of these parameters, we can switch the CPAP on. Confirm if OK. And now the ventilator, let's switch to the main screen. And now the ventilator delivers appropriate pressure. Let's see all parameters. We have the measured PEEP pressure, we have FiO2, we have all relevant parameters on the screen. We can also see on the screen trends. We can choose the time between 15 minutes up to 72 hours of trend. We can switch to simple view where we see only the FiO2 and the PEEP pressure. Let's change the mode to the last ventilation mode, which will be B-level. Finally, I will discuss the B-level mode and the parameters that can be set. In the B-level mode, in the first step, we have to decide which method of breath triggering will be best for our patient. We can choose between pressure supported spontaneous breath, this is the S mode, time triggered breath, this is the T mode, or combination of both methods of triggering inspiration, this is the ST mode. In the S mode, we can switch on the volume guarantee function. This is the function that allows the ventilator to deliver set tidal volume to the lungs despite of these unavoidable leaks around the patient interface, like mask or whatever we use. We also set the trigger level. This is in liters per minute, up to 20 liters per minute. The minimal set is 3. Oxygen concentration. The next screen allows us to set tidal volume, pressure limit. This pressure limit will determine whether the ventilator delivers this tidal volume or not. If the ventilator will have to deliver pressure higher than 25 centimeters of H2O, this volume will not be delivered. Next parameter is pressure assist minus. We know this parameter from CPAP mode. We also set EPAP, this is the PEEP pressure. We also set rise time and auto start function. The last screen, of course, allows us to set the humidifier. If we go back to the ventilation modes, the next ventilation mode is time-triggered breath. In this mode, the ventilator simply delivers mandatory breaths with the set rate, with the set respiratory rate. So in this case, every 6 seconds the ventilator will deliver another breath. The time of the breath is set here. This is the TI, inspiratory time. Let's go back to the first screen. So on the first screen we choose the timed mode. We switch on the volume guarantee. We can also change the oxygen, FiO2. On the second screen we set additional parameters like inspiratory volume, pressure limit, assist pressure, expiratory pressure, inspiratory time, respiratory rate, and rise time. Okay, let's move to the first screen and change the ventilation mode to ST. In ST mode, of course, the ventilator supports spontaneous breaths of the patient. That's why we again see the trigger level. We can also set volume guarantee, inspiratory volume, pressure limit. The pressure limit can be up to 45 centimeters of water. We can also set the respiratory rate in ST mode. If the patient does not trigger the breath before the end of breath cycle, the ventilator will deliver mandatory breath. This will be the timed breath. I believe that's all. Now, when we set all of those parameters, we can switch on the ventilator, and now the ventilator starts operating. I believe we have on the auto start. Yes, we have auto start on. If we switch it off, the ventilator starts immediately delivering breaths. Total leakage high, we get an alarm because the ventilator is not connected to the patient. So I squeezed one of the prongs, and now we have PEEP high. Okay, we can either change the alarm, let's set it to 33 and switch to the main screen where we can see delivered parameters. Now we can switch off the ventilator. I believe we covered all ventilation modes and all of the functionality of the device. I believe this is helpful. If any additional explanation is needed, if I can help in any other way, please let me know. Thank you very much.